so this is the last problem on homework number 6, which is vapor-liquid equilibrium for, or Raoult's law for adults. There's also azeotropes. This one, number 7, has azeotropes in it. I'm thinking for the sake of time, so it says, from the data in Kresge 8.25, which is basically azeotropic data, okay? So you got azeotropic data, and you're trying to find the A for the 2 suffix Margulis, okay? What is the bubble temperature if the vapor composition is this, and at this pressure, okay? I'm going to say you refer to the first homework problem, and yeah, refer to the first homework problem on how to get A. I'm not going to go over it again. I find it very repetitive and kind of tedious. So just kind of refer to number 1, okay? What I will go through is a bubble temperature problem, knowing, a bubble temperature problem with a non-ideal solution. Okay, so we did a bubble temperature with an ideal solution. Now let's do a bubble temperature without an ideal solution. Okay, but again, I gotta ask myself, what do I know, what do I don't know, and what do I have value for, and the equation. So my equation is YIP equals XI gamma I PI sat. I know XI, I know P, I don't know YI, and I don't know T. As a result, I don't know gamma I, and I also don't know PI sat. Okay. So there's very little I know, and there's a lot I do know. Okay. So I know this guy, and I know this guy, but I don't know that guy, I don't know that guy, and I don't know that guy. And again, I gotta ask myself, okay, how do I start this? Okay, but whenever I don't know, no, it's not so much when I don't know gamma do I assume it's equal to 1. It's only when I don't know xi do I assume gamma I is equal to 1. Okay. When I don't know the temperature, I'd rather go for the temperature first, because if I get the temperature, I kind of double whammy myself. If I guess the temperature, I can get the PI sat, okay, also in one fell swoop, okay. And so I want to guess the temperature. How do I guess the temperature? Well, I have the pressure, and so I can use reverse Antoine's, which says the Ti sat is equal to Bi over Ai minus natural log of P minus Ci. Okay, so I can use the summation of Xi Ti sats to get a guess for temperature. Okay. Oh yeah, because the other equation I need to have here is summation of y equals 1. Alright. And so I have a t guess, and now because I know xi, I have enough to get gamma I, I have enough to get pi sat. And you might be like, well, I don't have a. Well, that's why I said, like, use the approach for number 1 to get a. Once you have A, then you're good to go. Okay, I mean, it's kind of tedious otherwise. All right, so just watch that other video. All right, so I can get gamma I and I can get pi sat. Okay, and so now I have a value for those two, and I don't need to assume gamma 1 equals 1, and gamma 2 equals 1. Why? Because I have a temperature. Now you might be like, well, could you get your temperature by assuming an ideal solution? Well, I get a different temperature from each one, and so could I do that? Well, yeah, but really I wouldn't want to do that because I'm not really going to get a temperature that's going to work out the way I want it to. Okay, because because I'm assuming ideal solutions, so activity models are basically garbage anyways at that point. So it's just better to do it this way. Okay. But again, I look at that and it's saying, okay, I don't know yi. Okay, so yi is equal to xi gamma I pi sat over p. And okay, do I know I have a value for xi? I do. Do I know I have value for gamma I? I do. Do I know I have value for pi sat? I do. Do I know I have value for p? I do. So I have enough information to get a value for yi's. Okay. The problem is, so I have yi in that case. Problem is I'm not done because I guessed for the temperature. But I asked myself, what did I get a value for first? I got a value for T first, okay, so I need to update it, okay. How do I update it? Well, I know that T for component 1 is B1 over A1 minus natural log of P1 sat minus C1. The problem is, well, I already used my T guess to get P1 sat. And so if I did it this way, I get the exact same temperature back. So I need to change P1 sat somehow. Okay, I need to fudge it. Okay, how much do I fudge it by? Well, I want it to be close to 1. Do I have an equation that's equal to 1? I do. I have this equation right here. So summation of xi gamma I pi sat over p should equal 1, but it doesn't equal 1. It doesn't equal 1 yet, but it should be close to 1. And so I can use it as a fudge factor, omega, and fudge my P1 sat, specifically P1 sat, nothing else, to get a new temperature. And from that new temperature, I can keep moving on. And be like, well, shouldn't you do it to both? Well, that's more time. I mean, if I'm doing this by hand, I only want to fudge one of them, okay? So I'm going to fudge that one. So this goes a little quicker. And so, so I'm going to have P1 sat new is going to equal P1 sat old, and I want to fudge it. Now, how do I want to fudge it? Do I want to divide by the fudge factor, or do I want to multiply by the fudge factor? I want to divide because I always want P on top, okay? Why? Because it diverges otherwise. Otherwise, it's going to, if you make sure that P is going to be on top in terms of this thing, then, it's going to converge. Otherwise, it's going to diverge. So that's what I want to do. I want to divide by my fudge factor, and then I'll be okay. Okay. So I got a new P1 sat. I plug it in here. I get a new T. I got a new T, so I can get a new gamma. I can get a new P1 sat. I got a new gamma and P1 sat. I can get a new yi. I have a new yi. I can just keep iterating until I'm blue in the face, and eventually I'll convert.